At the edge of the north, the land announces its power without warning. Here, mountains move, oceans rise, and ancient ice can reshape a coastline in seconds. Every force released by this wilderness travels outward, disturbing lives far beyond its source. To understand Alaska, we must follow those forces from the frozen interior to the sea. This river of ice has been moving since long before any living memory began.
Yet even the oldest ice must answer to the mountains, the wind, and the changing seasons.
And when the weather turns, the transformation can begin before there is time to escape. Below these peaks lies open country, beautiful from a distance and merciless to anything exposed. Across it, entire generations move together, guided by routes older than the forests. For the youngest travelers, survival begins with a simple demand: never fall behind. Every difficult crossing is also watched by creatures searching for an opportunity of their own. The same water that tests the herd now gathers strength and continues toward the coast. Against that current comes another migration, driven not by winter, but by the promise of renewal. Their arrival awakens an ancient hunter whose year depends upon this brief abundance. Strength matters here, but patience and experience decide which effort will be rewarded. What the river provides will not remain beside the water. It will travel into the forest. There, a life born in the ocean becomes nourishment for roots, insects, birds, and trees. This is a northern rainforest, sustained by rain above and by the sea below. Beneath the giants of the forest, quieter lives depend on concealment rather than confrontation. But concealment leaves signs, and the coastal wolf has learned to interpret every broken branch. By controlling grazing animals, the otter protects shelter used by countless hidden inhabitants. Among them is a master of transformation, able to vanish without ever leaving its stone. But the forest offers only temporary shelter when larger hunters enter from open water. With its descent complete, the vessel enters a world governed by stillness, pressure, and time. Its position on the seabed will shape every current, shadow, and shelter that forms around it. At the point of impact, twisted plates expose layers of construction once hidden from the sea. Features designed for a horizontal world have been turned into entrances, ledges, and overhangs. Sediment immediately begins dividing the wreck into buried foundations and open spaces. Along the deck, collapsed railings create the first complex boundaries in an otherwise open landscape. The anchor chain extends beyond the hull, connecting the wreck to the surrounding seabed. Machinery once used to control movement now remains fixed in a position it was never built to endure. Every opening offers the current a new route through the vessel's steel frame. For passing animals, the wreck is still unknown, an immense structure without scent, food, or history. The forward cargo hold presents the largest entrance into the ship's hollow interior. Beyond the threshold lies a chamber once isolated from the ocean, now completely surrendered to it. The ship's angle has transformed floors into walls, and walls into sloping platforms. Overhead beams divide the chamber into smaller territories that do not yet have occupants. Water circulates through the opening, carrying oxygen and suspended material into the enclosed space. Gravity gathers loose material here, creating a soft floor upon the tilted steel. One solitary visitor tests the protection offered by the wreck, but does not remain. Even the smallest passage connects this interior chamber to the wider ocean. Farther aft, repeated compartments create a sequence of empty spaces waiting to be explored. Small pockets of air persist within the structure, escaping only when pressure opens a path. The central hold suffered greater damage, producing a more intricate network of cavities. A ladder that once connected decks has become a narrow bridge across open water. Where structures overlap, calm pockets form beyond the reach of stronger water movement. The chamber briefly attracts a passing school, yet its unfamiliar darkness keeps them moving. Above the holds, the superstructure contains smaller rooms shaped by an entirely different purpose. Its exposed bridge receives more water movement than the protected chambers below. Inside, navigation has lost all meaning. Direction is now determined only by current and gravity. The instruments remain in place, but the conditions they once measured have vanished. Even the compass stands powerless within a vessel that will never choose another course. The wheel has become a motionless frame through which the ocean quietly passes. Beyond the control room, connected passages carry water deeper into the superstructure. Each doorway slows and redirects the flow, producing a chain of distinct micro-environments. Rooms once arranged for daily life have become vertical chambers with inaccessible corners. Objects that could move have collected along one side, recording the direction of the final roll. The route downward leads toward compartments protected from both surface light and open currents. Here begins the densest and most mechanically complex region of the wreck. Engines, generators, and platforms fill the chamber, leaving only narrow channels between them. The machinery creates sheltered surfaces, though some remnants may delay the arrival of sensitive life. Broken pipes form tunnels of different sizes, extending the wreck's hidden interior. Through these accidental corridors, water can travel between chambers once kept completely separate. At the lowest point, invading sediment begins burying machinery from beneath. Occasional animals pass through, but no permanent community has yet taken hold. Behind the machinery, the vessel narrows as its internal structure approaches the propulsion system. The rear hold survived more completely, preserving a broad interior with fewer protected recesses. Outside again, the stern rises above an area where currents accelerate around the hull. The propeller now stands as a fixed obstacle, redirecting water instead of driving the ship forward. Beside the rudder, reduced current creates one of the wreck's calmest exterior spaces. Moving water scours the seabed here, carving patterns that reveal the invisible force of the current. Local fish continue their familiar routes, cautiously adjusting to the new obstruction. Flexible remains respond to every passing current, while heavier structures remain locked in place. One mast still stands, creating the highest point above the surrounding seabed. Its crossbars provide exposed surfaces where stronger currents deliver a constant supply of suspended material. The fallen mast has created a separate structure beyond the shelter of the main hull. Scattered pieces extend the wreck's influence across a much wider area of seabed. Lighter fragments remain unstable and may continue moving until sediment finally holds them. Beyond the debris, the seafloor returns abruptly to open sand with almost nowhere to hide. Together, these compartments create a new architecture, unlike anything that previously existed here. With the fading light, the wreck separates into exposed surfaces, shaded ledges, and permanent darkness. On every exposed edge, seawater is already reacting with metal at a microscopic scale. Before this metal tomb can support a living kingdom, the ocean must patiently transform its surface. That transformation begins with materials too small to be recognized from a distance. Proteins, minerals, and fragments of organic matter briefly attach themselves to every uneven surface. Together, they create a conditioning layer that changes how the surrounding water interacts with the hull. This altered surface is soon detected by microscopic pioneers drifting through the ocean. Some make contact only briefly, while others remain and begin establishing permanent colonies. As their numbers increase, the cells produce a protective matrix that binds them to the metal. To the larger animals passing nearby, the wreck remains unchanged, yet its chemical identity is already shifting. The first transformation cannot be seen by this visitor, but it will influence every community that follows. Development proceeds fastest inside small recesses, where the current cannot easily remove new arrivals. Beneath the hull, stable conditions support a different microbial balance from the exposed surfaces above.
Shelter, water movement, oxygen, and temperature determine which organisms can remain in each location.
At the wreck's highest point, constant flow prevents thick deposits from accumulating. But behind every bolt and joint, protected pockets allow microscopic communities to persist. Day after day, changing currents deliver new cells, nutrients, and chemical compounds from distant waters. Inside the holds, material carried through the open hatches gathers where circulation is weakest.
These quiet interior surfaces soon carry a continuous living film.
The film now contains enough organic material to attract the first microscopic grazers.
By feeding here, this tiny crustacean becomes one of the wreck's earliest mobile residents.
Others soon discover the same protected source of food and shelter. Against the scale of the cargo chamber, their presence appears insignificant, but ecological succession often begins this way. Over the following weeks, the microbial layer grows more complex and increasingly uneven. Different organisms settle at different depths, forming a community with its own internal structure. Where enough light reaches the wreck, diatoms add a new source of biological production. Even a small difference in illumination now separates one habitat from another. Below that narrow boundary, organisms must depend entirely upon material delivered by the surrounding water. Here, microbial communities survive by transforming dissolved compounds and particles into usable energy. Across a few centimeters of steel, changing oxygen levels support entirely different chemical processes. At the same time, seawater reaches exposed iron and begins converting solid metal into new compounds. Corrosion spreads beneath the remaining paint, gradually separating it from the hull. When the coating finally fails, another patch of raw steel is surrendered to the water. Below the wreck, these fragments begin forming a narrow record of its gradual decay. Damage sustained during the descent provides countless starting points for the process. Some microbes accelerate these reactions, while others alter the local chemistry in different ways. Over time, the products of corrosion accumulate into fragile structures extending beyond the original surface. These formations remain vulnerable, continually shedding material into the surrounding sea. Edges, welds, and damaged joints change fastest because more unprotected metal is available. Elsewhere, surviving paint delays the reaction and creates a patchwork of surfaces at different stages. This uneven landscape provides both food and shelter for a growing variety of minute animals. Within the smallest crevices, entire communities exist beyond the notice of larger creatures. Each hidden colony occupies only a fraction of the wreck, yet together they are changing its entire surface. As months pass, the bare uniformity of steel gives way to subtle biological color. The superstructure changes more quickly because its windows and broken panels allow water to circulate through both sides. Inside the bridge, protected frames support denser films than the exposed outer walls. Complex shapes provide sheltered attachment points where colonies can resist the passing current. For a small scavenger, even a steering mechanism can become a maze of protected pathways. Moving water carries this expanding food web deeper into the vessel. Here, organic coatings and settled particles combine to create richer feeding grounds. Small crustaceans begin remaining for longer periods, protected from the stronger flow outside. Their presence attracts a young fish seeking both food and refuge. Yet the deeper passages remain unfamiliar, and this cautious visitor stays close to an escape route.
In the engine room, thousands of pipes and joints multiply the available surface area.
Every broken tube creates another boundary between flowing water and protected interior space. Now, the first larvae of permanently attached animals begin selecting the most stable surfaces. Most fail to remain, but a fortunate few secure themselves and begin to grow. Beyond the hull, the propeller offers another stable foundation, protected from direct sediment burial. These delicate polyps introduce a new strategy, remaining fixed while allowing the current to deliver food. As food becomes more reliable, passing animals begin treating the wreck as a place worth revisiting. The transformation is still modest, but nearly every region now supports some form of life. Microbes have prepared the surface, grazers have discovered its food, and attached pioneers have claimed their first footholds. The silent structure is no longer merely decaying. It has begun supporting a community whose arrival will soon transform the wreck beyond. As the surrounding water becomes rich with drifting life, the number of potential settlers increases dramatically. Each larva must find a surface offering the correct texture, water flow, and access to food. Many continue their journey, but those detecting favorable conditions prepare to abandon the open water. Settlement demands a complete change of existence, turning a drifting traveler into a permanent resident. Repeated across the wreck, these individual decisions begin producing visible patterns of colonization. Hydroids expand by producing connected polyps, each sharing the resources gathered by the colony. Their position within the flow allows them to intercept food without moving from the steel. Flexibility protects these fragile hunters when faster water sweeps across the exposed structure. Behind the metal, reduced force permits taller and more closely packed branches to survive. The expanding colony now modifies the flow itself, creating tiny channels used by other drifting animals. Elsewhere, tube-building worms strengthen their position by surrounding their bodies with mineral shelters. Only the feeding crowns are exposed, filtering suspended particles, while the vulnerable bodies remain hidden.
The slightest disturbance triggers a retreat faster than the eye can follow.
Once danger passes, the colony returns to harvesting the continuous supply carried by the sea. Their distribution records an essential boundary between stable feeding grounds and areas repeatedly buried by sediment. Encrusting bryozoans now begin occupying the remaining open spaces between larger settlers. What appears to be a single crust is actually a cooperative colony composed of many specialized individuals. Growth continues until neighboring colonies encounter one another and compete for the same limited surface. The steel is no longer an empty foundation. Every new arrival must fit within a community already claiming space. Together, these organisms convert a flat metal surface into a complex three-dimensional habitat. Within calmer recesses, young sponges gain access to water carrying bacteria and microscopic organic matter.
Its body functions as a living filtration system, drawing nourishment from every passing current.
Growth succeeds only where the foundation remains stable enough to support a permanent body. Different species occupy neighboring surfaces, adding color to chambers once dominated by bare steel.
The hold is becoming a sheltered biological chamber, supplied by water circulating through its damaged entrance.
Shaded overhangs provide attachment sites for animals able to feed while suspended above the seabed. From this position, its tentacles reach directly into food, concentrated by the shape of the wreck. Even stationary animals can adjust their bodies to exploit subtle changes in water movement. Vertical position and shelter now divide the wreck into increasingly specialized neighborhoods.
As structural complexity increases, small mobile animals find places inaccessible to larger hunters.
Bivalves secure themselves in narrow depressions where their shells are protected from direct impact.
Like many residents of the wreck, it depends upon filtration rather than pursuit.
On the current-facing edge, barnacles occupy positions too turbulent for many softer-bodied settlers. Protected by hard shells, they repeatedly sweep food from water racing above the metal. Two different feeding communities can exist only centimeters apart, because each responds to the current in its own way.
Sea squirts settle where a steady exchange of water passes between the bridge and the open ocean.
Their simple appearance conceals an efficient system for filtering suspended food.
Some species reproduce across the surface, producing connected groups that share the same foundation.
Their bodies respond to disturbance by closing, protecting delicate internal structures until calm returns.
The broken windows no longer separate two spaces. They connect neighboring habitats with different levels of light and flow. The arrival of specialized grazers reveals that the attached community has become a dependable source of food.
Rather than consuming everything it encounters, this predator targets a narrow range of prey.
Different hunters follow different food, adding new links to the developing web.
For smaller grazers,
Every fold and crevice offers temporary protection from animals searching across the surface. What began as isolated settlement has developed into an interconnected community of producers, filters, grazers, and hunters. Around the stern, mobile scavengers collect material trapped within the growing layers of life. Even a moving shell can transport settlers from one region of the wreck to another. Material escaping from the wreck accumulates below, creating feeding opportunities along its edges. As residents increase in size, competition begins shaping who controls the safest shelters. Possession of this calm refuge provides reliable access to both shelter and food. Young fish now remain around the wreck, instead of approaching only for brief investigation. Abundant invertebrates provide a food supply capable of supporting visitors throughout the day. Some venture into the shelter, while the more cautious members maintain contact with open water. The chamber's beams divide the school into smaller groups and reduce the force of the surrounding current. Their reaction reveals another advantage of the wreck. Danger can be escaped in many directions. Larger fish are beginning to recognize that concentrated prey can be found around this rising structure. Its presence temporarily changes the behavior of every smaller animal nearby. Once the threat has passed, movement and feeding return to the exposed surfaces. Through the first year, repeated cycles of settlement, growth, competition, and loss steadily increase the wreck's biological complexity. The vessel now offers both food and refuge, and its growing population is beginning to attract hunters from far beyond the debris field.
The growing concentration of young fish has not remained unnoticed beyond the wreck.
Rather than charging immediately, the hunter approaches from a direction that carries its movement and scent away from the school. Sensitive organs along its body detect movements hidden by the wreck's complex structure.
The younger fish respond before the predator reaches them, compressing into a coordinated defensive group.
At the final moment, the wreck gives the school several escape routes that open in different directions.
Instead of fleeing into open water, the fish use separate chambers of the vessel as temporary shelters.
Its larger body provides strength and speed, but prevents it from entering many of the narrowest passages. The same structure that shelters the school also protects the smaller animals upon which it feeds. The first attempt fails, but the hunter has begun learning how prey moves through this unfamiliar architecture. By waiting near a major exit, the predator converts part of the wreck into an ambush point. Valuable hunting positions soon attract competitors of similar size. Size and posture communicate strength before physical conflict becomes necessary. The smaller rival withdraws, avoiding an encounter that could cost more energy than the feeding ground is worth. For the moment, control of the central opening belongs to a single hunter. Not every predator announces its arrival through size or speed.
Camouflage allows this hunter to remain unnoticed only centimeters from its prey.
A single burst completes the hunt before nearby animals can react. For the smallest fish, survival depends upon recognizing shelter faster than the predator can strike again. As suitable refuges become occupied, competition develops even among animals that rarely leave the surface. The wreck has become a vertical neighborhood in which body size and behavior determine where each resident can live. With the approach of darkness, the balance of activity begins to change. A hunter concealed throughout the day now prepares to enter the open wreck. Its narrow, flexible form allows it to travel through passages inaccessible to the larger cod. Chemical traces carried from the interior reveal the presence of animals hidden beyond sight. Within the chamber, nighttime scavengers have emerged from countless mechanical recesses. The machinery forms a hunting ground of barriers, blind corners, and narrow escape routes. Success depends not upon speed alone, but upon searching every opening where prey may hide. Even this flexible predator encounters boundaries created by the wreck's complicated interior.
Avoiding a predator often requires movement at precisely the moment its attention turns elsewhere.
Its search continues through a network of exterior shadows connected by broken steel. While some hunters enter the wreck after sunset, many young fish move above it to reduce the danger of being cornered.
Individuals of different ages occupy different positions according to their swimming strength and vulnerability.
From the surrounding darkness, more mobile hunters approach the biological signal created by the wreck.
Their bodies are designed for open movement, so they remain beyond the most obstructed parts of the structure.
Once again, the vessel becomes a defensive landmark within an otherwise exposed water column.
The mast disrupts the attack by dividing the school and forcing the hunter to change direction.
A structure built for transportation now breaks the geometry of an ocean hunt. Some hunters remain to search for another opportunity, while others conserve energy and move on. Even the smallest exterior refuge becomes valuable when danger controls the open water. When the hunters leave, the scattered school reunites around the familiar outline of the wreck. At smaller scales, darkness brings a different community into the moving water. Animals hidden during daylight now leave their shelters to collect suspended food and organic fragments. The attached colonies intercept material that later supports mobile scavengers. As the wreck matures, deeper cavities provide secure daytime shelters for increasingly powerful residents. Their feeding routes intersect where organic debris accumulates along the hatch rim.
A short display resolves the dispute without the risk of prolonged combat.
Control of the feeding site provides access to the concentrated remains carried here by the current.
Slower predators also exploit the growing community, following prey that cannot leave the steel. The muscles respond by closing, but remaining fixed makes them vulnerable to a patient hunter.
Across the wreck, every successful colony now supports another animal capable of feeding upon it. The return of daylight reverses the nightly movement, sending many exposed animals back into shelter. After searching through the wreck, the eel withdraws to the same protected chamber before visibility increases. In the shelter, a temporary truce allows small cleaners to remove parasites and damaged tissue. For the predator, tolerating these vulnerable visitors provides a benefit greater than immediate feeding. With daylight restored, the wreck's daytime population resumes feeding above the structure. The largest resident hunter begins another circuit through the territory it defended the previous day. Different levels of the wreck now support distinct communities linked by movement, feeding, and danger. Growth does not proceed in a straight line. Every season brings expansion, disturbance, competition, and renewal. Some creatures use this structure for only a few minutes,
while others will spend nearly their entire lives upon it.
By attracting both prey and predators, the wreck has become a true center of life, but the growing community will soon face the full force of the changing sea. The first sign of approaching danger appears not in the sky above, but in the accelerating water surrounding the wreck. A distant storm is transferring its energy downward, transforming the gentle morning flow into a powerful seabed current.
The school must spend increasing energy simply to remain near the shelter it has come to depend upon.
Even the largest resident abandons its usual patrol and seeks slower water close to the structure. For smaller fish, the open hatches provide immediate access to chambers shielded from the strongest flow. Each beam divides the current, creating pockets where the fish can conserve precious energy.
Attached animals cannot retreat into the wreck, so survival depends upon flexibility and the strength of their attachment.
Soft-bodied residents reduce their exposed surface, presenting as little resistance as possible to the rushing water.
The current now carries abrasive sediment capable of damaging every delicate structure left exposed. Strong attachment threads secure the mussels within depressions where the metal shields them from direct force. As the storm intensifies, the seabed itself is drawn into motion. Sand advances across the bottom in waves, burying some habitats while uncovering others.
Powerful flow removes the seabed supporting the bow, deepening an erosion hollow known as scour. Once freed from the sediment, the heavy chain begins moving for the first time since the wreck came to rest. Colonies that survived feeding and competition can still be removed within seconds by mechanical force. Corrosion has weakened the structure, allowing metal once designed to resist the ocean to flex beneath its power. Every repeated movement places new strain upon connections already damaged by impact and rust.
A single failed fastening changes the pressure around the entire plate.
The new opening connects another sealed cavity to the surrounding sea. For the animals occupying this hidden chamber, protection disappears without warning. Small residents survive by finding the narrow boundary where moving water meets a pocket of calm. Even sheltered spaces are affected as suspended material enters through the open hatches.
Filter feeders must stop processing water when the current carries more sediment than food. Across the superstructure, tunicates close their siphons to protect delicate internal filters. At the storm's peak, the once calm wreck becomes the center of a turbulent underwater landscape. Material carried from distant rocky shores becomes trapped by the highest remaining structure. Even temporary debris increases resistance, placing additional pressure upon weakened metal. Beyond the hull, erosion begins moving fragments that appeared permanently fixed within the debris field. A refuge can vanish as quickly as it formed, forcing its residents to search for another. Although the day is not over, the water now resembles the approach of night.
Within the steel, repeated pressure exploits weaknesses created by 2 years of corrosion.
The load is no longer shared evenly, concentrating stress upon the few connections that remain. At last, the weakened wall yields, opening a chamber sealed since the sinking. Water enters the chamber and releases years of accumulated material into the storm.
The fish respond instantly, abandoning familiar routes before the changing structure can trap them.
The movement is small, but the architecture of the wreck has been permanently altered. Some pathways close as others appear, continually reorganizing the interior habitat. The resident eel can no longer remain inside the cavity it has used through countless daylight hours. Flexibility allows it to relocate through passages that remain unreachable to larger fish.
Other residents remain within their shelters, using powerful legs to resist the water outside.
After hours of sustained force, the storm begins to release its grip upon the seabed. As energy fades, suspended material descends upon every horizontal surface. The vessel has survived, but it no longer presents the same landscape to its inhabitants.
The break has created bare surfaces, untouched by the community that covered the exterior. Colonization begins again almost immediately, repeating the first biological step on a newly created foundation. Some sponges can survive fragmentation, allowing broken tissue to establish new growth where conditions remain favorable. Flexible colonies that remained attached return to feeding before the water has completely cleared. Protected beneath the overhang, many anemones endured the storm with little permanent damage.
A difference of only a few centimeters has separated survival from burial.
For some predators, the disturbance has created opportunities hidden beneath the fresh layer of sand.
Scavengers are among the first mobile animals to exploit the material released by structural failure.
The fish must rebuild their mental map of a structure that changed within a single day.
The collapse has created another escape route, too narrow for the wreck's largest resident hunter.
Within hours, the school begins incorporating the altered chamber into its daily movement. What serves as an escape route during daylight may become a hunting corridor after darkness. Bent steel creates new pockets of calm, and calm water immediately begins gathering food. Even displaced debris produces new shelters for animals capable of recognizing opportunity. During the following months, recovery and recolonization soften the boundaries between old habitat and newly exposed steel. Disturbance has destroyed part of the community, yet it has also increased the variety of surfaces, openings, and shelters. Dissonance. The wreck endures by changing, and every collapse begins another cycle of loss, opportunity, and life.
The next transformation begins with water arriving from far beyond the debris field.
As spring sunlight returns to the North Atlantic, microscopic plants multiply throughout the upper sea. The bloom feeds vast numbers of tiny, drifting animals, each carrying energy deeper into the ocean. The open chambers intercept this seasonal abundance and deliver it directly to the wreck's resident filters.
Colonies damaged by the storm now receive the food required for rapid recovery.
Every exposed tentacle converts the passing bloom into growth. Fixed animals that cannot search for food depend entirely upon what distant currents bring. The seasonal supply allows surviving fragments to spread across steel exposed by the storm. Animals living below the deck rise toward positions where the concentration of drifting food is greatest.
For a brief season, many different species depend upon the same invisible harvest. Mixed with the plankton are the young of animals born many kilometers from this wreck.
Before settling, each larva samples the foundation upon which it may spend the rest of its life.
A suitable hollow ends its drifting journey and begins another permanent colony.
Other settlers occupy the surrounding steel, gradually closing the empty spaces left by disturbance. The wreck's altered shape offers protected conditions for species unable to survive on exposed surfaces. Only a small fracture remains here. Most continues toward other reefs, rocks, and distant wrecks. The wreck does not merely receive life from elsewhere, it also sends new life outward. Some residents produce free swimming stages capable of traveling far beyond the steel. Through reproduction, the wreck becomes connected to habitats that may never appear within the same camera frame. Its isolation is only physical. Biologically, it has become part of a much larger network. The same bloom supporting the attached community now attracts fish arriving from open water. Thousands of coordinated movements allow the school to feed while maintaining awareness of danger. Permanent residents now share the water column with travelers following seasonal food. Each species occupies a different layer according to its speed, diet, and need for shelter. Concentrated prey draws the wreck's resident hunter away from its familiar patrol. A coordinated wall of bodies makes it difficult for the predator to isolate a single target. The hunter enters the school, but every nearby fish turns before its jaws can close. Once again, the wreck interrupts the geometry of the chase. Multiple hunters reduce the value of the lower shelter and push the school toward a more exposed layer. The pollocks know every entrance, but the visiting herrings depend upon speed and collective movement. The disturbance created by the feeding school attracts hunters capable of traveling across a much wider territory. Different predators divide the hunting ground according to their bodies and methods. Pressure from below transforms thousands of individuals into a single moving shape. The wreck provides obstacles, but unfamiliar passages can also divide the visitors from their companions. A shelter used easily by resident pollock becomes confusing to fish adapted to open water. Collective movement restores their defense before the hunters can exploit the separation. When the energy cost becomes too high, each hunter returns to a strategy better suited to its body. The visitors remain only while food and safety justify the journey. The visitors remain only while food and safety justify the journey.
After the migration passes, the permanent community returns to its familiar arrangement.
A brief event has transferred energy from the open ocean into the wreck's local food web. Another visitor approaches, but this time it arrives alone. A gray seal has followed fish from distant coastal waters to this submerged landmark. Powerful lungs and efficient blood chemistry allow this mammal to search far below the surface. Sensitive whiskers detect water disturbances left behind by prey moving through the wreck. The residents retreat into spaces too narrow for the visitor's broad body. Experience keeps the hunter outside passages where sharp edges and collapsing steel would make pursuit dangerous.
Larger prey cannot disappear into the smallest openings and must rely upon speed.
The vertical structure breaks the pursuit and costs the seal valuable time and oxygen. A familiar shelter gives the resident one final advantage over the traveling hunter. With its dive nearing an end, the seal must return to the surface regardless of the hunt's outcome. Its visit connects this deep refuge with breeding and resting grounds along distant coasts. When the mammal departs, the survivor returns to a territory it understands in exceptional detail. At every scale, activity resumes once the unfamiliar disturbance has passed. Throughout the productive season, visitors arrive and depart according to currents, food, and opportunity. New generations discover the wreck and learn to use its openings as shelter. Local residents and wide-ranging travelers now exchange energy across every level of the structure. Meanwhile, microscopic arrivals continue rebuilding the foundation beneath the larger animals. Life moves in both directions, making the wreck a receiver, a nursery, and a source. What appears to be an isolated island of steel is now connected to distant habitats by every animal and current that passes. The wider ocean has found the wreck, but as more generations depend upon its shelter, the aging steel beneath them is preparing to change once again. The aging steel is already changing, even when the wreck appears completely still. Salt water penetrates every fracture, allowing chemical reactions to consume the metal from within. Communities of microorganisms also influence the exchange of iron, oxygen, and minerals along the surface. Layer after layer is released, gradually reducing the thickness of beams that once carried enormous loads. As the steel disappears, its smallest weaknesses become new habitats. For a small fish, structural decay can create shelter before it becomes a threat. The residents continue using familiar passages, unaware of how little steel now supports the spaces around them. To the larger residents, the early signs of failure are little more than another movement in the water. Another annual cycle exposes the structure to changing temperature, oxygen, currents, and sediment. Winter currents remove more of the seabed, supporting the vessel's forward weight. The movement measures only centimeters, yet it transfers pressure into every connected deck and frame. A fracture begins following the weakest line between two large openings. The animals fixed to the surface cannot move away from the growing divide. For attached colonies, a change in the foundation becomes an immediate ecological disturbance. Mobile residents respond to movement long before the structure completely fails. Metal that once resisted bending has lost much of its original strength. When the connection finally breaks, the beam can no longer distribute the load. A passage followed by generations disappears within seconds. The school immediately searches for another route through the structure. The same collapse that removes one habitat creates another at a smaller scale.
Within hours, a mobile resident begins investigating the newly formed shelter.
Changed water movement concentrates food along the boundary of the fallen steel. The new pocket of calm quickly supports scavengers feeding upon material carried inside. Above them, the larger structural change continues. Living colonies bridge the divide only until the movement exceeds their flexibility. Attached residents are transported with the surface beneath them. Strong attachment allows many soft-bodied animals to survive the change itself. When the movement stops,
an entirely new chamber remains.
Its entrance favors smaller residents, changing which species can use this part of the wreck. After darkness, the wreck's most flexible hunter explores the newly connected spaces. The chamber provides concealment for the hunter, but multiple exits still favor smaller prey. Survival often depends upon remaining invisible, while danger moves only centimeters away. The new route expands its hunting territory, even when the first search brings no reward.
By morning, the wreck presents a different landscape to every resident.
Repeated movement teaches the school to replace an old passage with a new one.
Changing architecture alters the balance between pursuit and escape.
Returning travelers must also interpret a landmark that no longer matches their previous experience.
Its search is guided by movement and water disturbance, rather than a fixed memory of steel. The altered refuge protects its smallest residents from a hunter built for open pursuit. During the following months, biological growth begins disguising the difference between old structure and recent collapse. Each new orientation favors a different community of attached animals.
Shade, current, and sediment now create conditions unlike those on the exposed hull.
Even opposite sides of the same plate begin supporting different forms of life. Structural decay increases the number of environmental layers contained within the wreck.
But every new habitat still depends upon steel that continues to lose strength.
The highest structure now acts as a lever against its own weakened foundation.
A fracture circles the final connection between the mast and the deck.
The school recognizes the growing disturbance and moves toward the cargo holds. After decades of resistance, the final connection gives way. The fall extends the wreck's physical boundary far beyond the hull. A vertical landmark has become a horizontal corridor.
The fish begin exploring a route that did not exist the previous day.
Within hours, the fallen structure begins supporting life at several scales. Within hours, the fallen structure begins supporting life at several scales.
The new corridor also modifies the geometry of future hunts.
Familiar shelter and a newly fallen obstacle combine to protect the resident school.
The mast begins a second ecological life in its new position.
Burial removes some surfaces as colonization transforms others. The wreck is no longer a preserved ship, but a shifting mosaic of chambers, ledges, corridors, and debris.
Life does not require the vessel to remain intact. It requires only surfaces, shelter, food, and time.
As steel breaks apart, the seabed begins reclaiming the wreck from below, and the slow process of burial will create.
The seabed has begun entering the vessel, grain by grain, through every opening created by corrosion.
Each current carries sediment upward, then gravity draws it into the deepest chambers. Inside the wreck, steel interrupts the flow and reshapes the seabed into small migrating dunes. For the smallest scavengers, burial can erase an entire habitat within minutes. Mobile residents respond by climbing above the advancing layer.
A shelter used for many seasons becomes uninhabitable when its entrance begins to close. The wreck is losing vertical space from below, even as corrosion removes its strength from above. Below the visible surface, oxygen becomes scarce, and an entirely different community begins to dominate.
Burrowing worms thrive where organic particles collect between metal and sand.
At the surface, brittle stars recover food before it sinks beyond their reach. The wreck slows the current, allowing organic remains from the water above to accumulate within protected hollows. Burrowing animals mix oxygen and nutrients through layers that would otherwise remain still. Where steel meets sand, the firm boundary supports burrows that open directly into feeding currents. The growing field of sediment attracts hunters adapted to disappear upon open sand. The residents increasingly remain above the buried chambers, leaving the lower habitat to animals of the seabed. Burial does not proceed at a constant rate. Every change in current can reverse part of the process. Across the year, the boundary moves repeatedly, exposing old surfaces before covering them again.
The strongest water movement transforms settled grains into a flowing cloud. Multiple openings funnel the moving seabed directly into the vessel. When the current weakens, part of the displaced seabed remains trapped inside. One chamber now contains two worlds: open water habitat above and buried habitat below. Animals fixed too low on the structure cannot escape the accumulating layer.
A small difference in elevation determines whether feeding can continue.
Above the sediment line, suspension feeders still receive an uninterrupted supply of food. Some residents temporarily reduce feeding until abrasive particles have passed. Others remove sediment repeatedly while remaining permanently attached. The most flexible colonies survive by yielding to the current rather than resisting it. Burial reorganizes the community according to height, mobility, and tolerance for sediment.
The mast's second life as a horizontal corridor is also beginning to disappear.
Shelters created by collapse remain temporary wherever the seabed continues to move. As one community retreats, sediment-dwelling species occupy the same location. The remaining steel concentrates drifting food along a boundary only centimeters high.
Suspension feeders must continually occupy the highest available surfaces.
While sediment enters the wreck, faster water removes support from its exposed outer edge. A cavity grows beneath the heaviest surviving section of the vessel. Eventually, gravity forces the weakened structure into the space below. The movement transfers pressure through walls already thinned by decades of corrosion. Mobile residents abandon the chamber before its final shape is established. Another vertical surface becomes a low shelter resting upon the seabed. The collapse destroys an old chamber, but produces a protected hollow along its boundary. For several hours, the consequences extend beyond the point of failure. The vessel's outline has moved closer
closer to the shape of the surrounding seabed.
The school transfers its daily route to the highest remaining structure. The school transfers its daily route to the highest remaining structure.
A new boundary also provides the larger hunter with an effective waiting position. The wreck's flexible hunter now encounters passages that are closing from below. It relocates to a shelter created by an earlier collapse and not yet claimed by the sand. Other residents also move upward, following the retreating boundary between steel and sediment. The available nursery space has become smaller, concentrating young fish into fewer protected openings.
The surviving shelters are separated, forcing the new generation to use several smaller territories.
Reduced shelter increases exposure, yet the remaining gaps still exclude larger hunters.
Multiple escape routes allow the school to survive within a structure that is steadily shrinking. A returning visitor finds that the familiar landmark has changed once again.
The hunter searches the remaining edges, but avoids the narrowing chambers beneath them. Its brief visit ends, while the slower transformation of the seabed continues without pause.
Across successive years, recognizable parts of the vessel disappear beneath migrating sediment.
What once formed the interior of a ship now resembles a series of natural reef ledges. Hard surfaces and soft seabed now support neighboring communities within the same small area.
The wreck is no longer only a shelter. Its material is gradually entering the chemistry of the seabed.
The ship remains visible, but its boundaries have begun dissolving into the landscape around it. Above the sand, the reef continues to change, but beneath it, sealed chambers and buried steel are creating a hidden world that daylight can no longer reach. Beneath the visible reef, a second habitat exists, inside spaces almost sealed from the ocean above.
Only a small exchange of water now reaches these buried passages.
Close to the opening, enough oxygen remains to support mobile scavengers. Farther inside, circulation weakens, and oxygen is consumed faster than it can be replaced. A narrow transition separates the active surface community from the oxygen-poor world below. Where larger animals become scarce, microorganisms dominate the process of decomposition.
They recover energy from material that has descended from the productive waters far above.
Chemical reactions between iron and sulfur begin darkening the sediment around the wreck.
Specialized bacteria occupy the narrow frontier where reduced chemicals encounter traces of oxygen.
Even one burrow can carry oxygen several centimeters into an otherwise depleted layer.
Animal movement creates temporary pathways through a chemical boundary invisible to the eye. Minute animals continue living within spaces far too small for the wreck's familiar residents.
Where water exchange remains possible, buried filter feeders maintain contact with the ocean above.
Its survival depends upon avoiding the grains that continually threaten to close the passage.
Only centimeters away, the open reef and buried ecosystem operate under completely different conditions. The same piece of steel connects sunlight, shelter, sediment, and oxygen-poor darkness. Exposure determines how the metal changes, producing contrasting surfaces above and below the seabed.
Hidden beneath the sand, the steel continues weakening without the visible movement seen above. Every new hole alters the exchange between the chamber and the surrounding seabed.
Sediment follows the new routes, gradually replacing the remaining volume inside. Corrosion and burial now work together, one removing structure as the other fills the space left behind. Newly exposed surfaces are investigated almost immediately by the smallest mobile residents.
Microbial colonization begins before the fragment has completely settled into the seabed.
Animal movement mixes material from the wreck into the surrounding sand. Over time, the chemical influence of the wreck extends beyond its remaining physical outline.
Beyond the immediate boundary, ordinary seabed conditions still dominate.
Burrowing animals attract predators that search for movement beneath the sand. Even the buried community remains connected to hunters moving across the surface. The boundary between steel and sand now supports food chains extending from microscopic life to large fish.
Darkness brings a flexible hunter across entrances too narrow for larger predators.
Water movement and scent reveal prey hidden beyond the reach of vision. The advancing sediment has created a refuge that favors the smaller animal.
As familiar passages close, the hunter must repeatedly alter its route. Not every concealed space remains permanently isolated. A brief increase in oxygen immediately expands the area available to mobile life. But when circulation fades, oxygen consumption begins closing the temporary refuge again.
Mobile animals retreat, while organisms adapted to the sediment endure the changing conditions. Throughout the year, buried passages breathe according to the movement of the sea above.
The seabed can also surrender surfaces it once reclaimed.
Isolation has transformed the metal into a surface unlike the bright orange wreck above. Contact with open seawater begins another cycle of chemical change.
Mobile colonists exploit the exposed surface before permanent settlers can establish themselves.
Once circulation becomes reliable, a new generation of attached animals begins rebuilding the community.
Colonization proceeds, even as the surface remains threatened by burial. A difference of only a few centimeters again separates survival from burial. For larger residents, erosion has restored part of an older route.
The same change that opens a corridor also creates a new ambush position.
Collective awareness prevents the school from entering the narrow space below.
When concealment fails, the hunter conserves energy and searches elsewhere.
Far below the marine animals, like a pod of dolphins, another change is beginning within the foundation.
Erosion removes support from ribs weakened during years of burial.
Once uncovered, the thin metal must again carry a load it can no longer resist.
Mobile residents respond to the disturbance before the structure begins to move.
Gravity lowers another section of the wreck toward the seabed. For a brief moment, water sealed inside the wreck returns to the surrounding ocean.
the chemical signature is diluted within an ocean vastly larger than the chamber that released it. Every structural movement destroys one passage and produces another. Within hours, life begins testing the new boundary. The wreck now supports connected worlds above, beside, within, and beneath its disappearing structure. The hidden chambers continue their quiet transformation, but a larger movement of the seabed is approaching, one capable of reshaping the entire reef. Upstream, countless grains are advancing together, driven by the strongest currents of winter. Each ripple migrates as grains are lifted from one side and deposited upon the other. The movement is almost invisible from moment to moment, yet persistent enough to erase the marks of life. Animals able to detect pressure and shifting grains begin leaving before their tunnels are buried. Even a hunter adapted to the seabed must move when the seabed itself begins to travel. The first grains encounter pieces of the vessel already separated from the main structure. A feeding surface exposed for years vanishes beneath a layer only centimeters deep. The mast interrupts the flow, converting a narrow steel ridge into a barrier against the moving seabed. One side experiences stronger erosion, while the opposite side receives the grains removed from the current. Suspension feeders follow the shrinking ridge upward, seeking water that remains clear enough to carry food.
Small residents transfer from temporary shelters to steel still rising above the sand.
The moving edge concentrates worms, fragments, and organic particles displaced from the seabed. The new boundary offers food, but its turbulent water favors only animals able to remain close to the bottom.
Within a season, a structure once extending into open water is reduced to a line across the sand. After crossing the debris field, the sand divides around the largest surviving obstacle. On the upstream edge, the current removes sediment faster than the approaching field can replace it. The channel expands as its unsupported edges collapse into faster-moving water.
Erosion reveals steel that has remained concealed beneath the seabed for several winters. A community adapted to darkness is suddenly exposed to moving seawater. Mobile grazers are the first larger animals to exploit the surface returned by erosion. Recognizable parts of the vessel briefly reappear before corrosion and sediment transform them again. An exposed entrance does not always restore the shelter that once existed behind it. Even an unusable passage can provide protection along its outer edge. The resident school quickly incorporates the newly revealed boundary into its daily route. Erosion has also created a deeper ambush position beneath the school. Collective movement allows the school to respond before the concealed hunter can close the distance. The opportunity passes, but the new hunting boundary will remain. While the port edge is being uncovered, the sheltered side is disappearing beneath the same current. A nursery created by collapse now loses its depth as the seabed rises within it.
The youngest residents retreat upward before their shelter closes completely.
As open water shelter disappears, sediment-dwelling animals replace its former community.
A hunter, guided by memory and scent, discovers that another familiar passage has narrowed.
Loose sand makes the remaining tunnel unstable and difficult to navigate. A shelter lost on one side of the wreck is replaced by a new corridor on the other. The newly uncovered structure is already being divided between residents of different sizes. Without direct conflict, each animal selects the space its body can use most efficiently. The transformation accelerates when a distant storm increases the movement of water across the seabed. As visibility declines, the community compresses around the most stable remaining structure.
Attached animals reduce their feeding, while sand passes across their delicate tentacles.
Each fixed resident relies upon a different defense against the sediment-bearing flow. Feeding structures designed to capture plankton must be protected until the water clears. The storm current drives part of the migrating seabed directly into the vessel. Residents closest to the floor abandon the chamber before the new layer reaches them. The shelter survives, but its shape and access routes have changed once again. Sediment adds support beneath part of the plate, even as the current increases pressure above it. The plate does not collapse completely. It lowers until the seabed carries its weight. A vertical chamber has become a low tunnel, accessible only to smaller residents.
Body size now determines which animals can use the transformed forward hold.
After hours of movement, the water slowly releases the grains it has carried. When the water clears, the residents encounter a reef with different boundaries. One event has lowered one side of the wreck and uncovered another. Freshly uncovered steel immediately becomes available to a new generation of colonists. Pioneer animals prepare the surface for a more complex, attached community. At the same time, the buried side develops a community adapted to soft sediment. A nursery for young fish has become the hunting ground for an animal concealed within the seabed. The altered landscape changes their route before any pursuit begins. A seasonal visitor returns to a landmark that now rises less clearly from the seabed. The reef has lost height, yet its smallest openings still protect fish from a hunter built for open water. After the winter disturbance, biological activity begins rebuilding order across the transformed wreck. Spring delivers a generation small enough to be carried wherever the current allows. Among them are barnacle larvae, searching for a permanent surface upon which to complete their transformation. They test the chemistry, texture, and stability of the steel before committing their entire adult lives to one location. Eretion only millimeters deep can provide enough protection for settlement to succeed. Different colonists favor neighboring surfaces, beginning a community too small to be seen from above. Future suspension feeders choose positions where moving water will deliver food without tearing them away. Height above the seabed determines which surfaces remain clear enough for attached life. On the sheltered side, the same sediment that protects the wreck also prevents many colonists from surviving. A slight difference in elevation separates surfaces that disappear from those that remain alive. The arrival of larvae is supported by another seasonal event, the rapid growth of microscopic plants. Diatoms use returning light
and winter-supplied nutrients to multiply across the water column. The bloom transfers energy into animals capable of feeding fish and growing colonies below. Young pollocks leave their shelters briefly to exploit the seasonal concentration of prey. Every excursion balances opportunity above against protection within the reef. Some members of the arriving generation are fish seeking shelter before they can resist the current. The wreck slows the water, creating retention zones within an otherwise moving sea. Predators also recognize the seasonal abundance, yet the narrowest spaces favor the youngest prey. When the current disperses the concentration, waiting becomes more costly than searching elsewhere. Other larvae select protected surfaces where their delicate attachment threads can resist the moving water. Worms convert loose material into permanent tubes, adding new texture to the steel. Within weeks, successful settlers begin changing from temporary arrivals into part of the reef. Bryozoans expand by producing connected individuals that share the same exposed surface. Hydroids extend feeding structures into water now filled with microscopic prey. As attached colonies gain height, mobile animals begin using the structure they create. New growth attracts specialized grazers capable of turning the colony itself into food. The colonist becomes habitat, prey, and nursery within the same expanding community. Larger grazers search between colonies, shaping the spaces that remain available. Even the path of a single grazer can determine where later settlers find room. The struggle for space begins long before the reef appears crowded to larger animals. Water that once threatened settlement now keeps successful colonies clear of smothering grains. But every grain removed from one surface must settle upon another. The last elevated section of the mast survives as an isolated feeding station. For suspension feeders, the seasonal bloom rewards every centimeter gained above the sand. Even this shrinking ridge receives a new generation before burial can reclaim it. Colonization continues beside a boundary that is still moving. Mobile suspension feeders can relocate, but only while elevated steel remains available. Erosion briefly returns another piece of the old structure to open water. The first explorers arrive before permanent attachment can begin. A surface hidden through winter re-enters the same cycle of settlement and competition. Across the larger reef, spring productivity is now influencing every level of the community. The resident school feeds upon larger plankton drawn into the current above the wreck. Body size separates the school into feeding zones with different risks and rewards. Below them, the reef's largest resident follows the concentration of potential prey. Hundreds of individual reactions transform the scattered feeders into a single defensive formation. The wreck breaks the hunter's approach into routes the school can navigate more quickly. Shelter and collective movement end the pursuit before contact occurs.
The unsuccessful hunter resumes a position where patience consumes less energy.
Beside the hunter, another resident benefits from the improved seasonal circulation. Material descending from the bloom delivers food even to animals that never enter open water. Darkness transfers activity from visual hunters to animals guided by scent and vibration.
The spring nursery remains protected by a ceiling too low for the larger hunter. Denied access to one opportunity, the eel redirects its search toward exposed prey. The wreck's smallest remaining layers can still decide the outcome of an encounter. With daylight, the reef changes occupants without ever becoming inactive. Through late spring, the microscopic arrivals develop into visible layers of living structure. In protected recesses, young mussels reinforce their attachment as the current strengthens. Every new branch, shell, and tube multiplies the number of spaces available to mobile life. The reshaped wreck now supports two neighboring reefs, one rising into the current and one living within the sand. From a distance, the spring community has restored movement and abundance to a structure steadily losing its original form. The smallest arrivals have rebuilt the foundation of the food web, and now their abundance is drawing an entire migrating population from the open sea. From beyond the reef, thousands of herring arrive as part of a migration older than the vessel below. By swimming together, individuals reduce their exposure while navigating unfamiliar water. Every turn produces a pulse of reflected light, allowing movement to spread rapidly through the school. The wreck interrupts the formation, but the school separates without losing coordination.
Migrants and residents briefly occupy the same water, yet depend upon different parts of the reef.
The spring bloom provides fuel for the final stage of their journey.
A dense band of prey holds the fish above the wreck, despite the risk of open water. Younger residents exploit the disturbance without abandoning the protection of the reef.
Below the abundance, the wreck's largest resident waits for a formation to weaken. A single movement beneath them travels through thousands of fish as a collective warning. Speed and synchronization allow the school to turn more rapidly than the solitary hunter. When the formation remains intact, pursuit would waste more energy than it could provide. Feeding is not the migration's only purpose. The adults are also searching for a suitable spawning ground. The first fish inspect areas where moving water has removed the finest sediment. Eggs deposited here would receive oxygenated water without being carried away. Contact with the seabed helps confirm whether the surface is firm enough to hold adhesive eggs. The sheltered side is unsuitable because shifting sand could bury an entire generation. The wreck has altered the current enough to preserve small islands of coarse seabed.
As spawning approaches, the school reorganizes according to sex and position.
Lower light provides the signal for activity to intensify. A female releases thousands of eggs that attach wherever they touch the solid seabed.
Males follow within seconds, allowing fertilization to occur before the current dilutes their contribution.
The spawning wave spreads through the aggregation, transforming exposed stones into a nursery.
The vessel's scattered remains extend the amount of stable surface available.
Each egg remains fixed, but those beneath thick layers may receive less oxygen than those above. Small differences in water movement will determine which embryos develop successfully.
The new generation immediately becomes a concentrated source of food.
While spawning continues, the movement of adults delays some of the first egg predators.
The concentration is now large enough to attract a hunter from beyond the wreck.
The school uses both collective motion and the wreck's complex outline to resist the approach. Steel divides the pursuit, giving the smaller fish more routes than the larger hunter can follow. Resident fish respond to the disturbance by entering spaces the migrants cannot use. A new angle briefly separates several herring from the protection of the formation.
The last ridge of the mast becomes a temporary landmark during their escape.
Repeated acceleration is costly, and an intact school offers few easy opportunities.
When the hunter leaves, spawning continues where it was interrupted. Through the night, the last adults complete their investment in the seabed.
With spawning complete, the adults gather before returning to feeding grounds beyond the reef.
Morning reveals a nursery containing millions of embryos fixed to the transformed seabed. The migrating adults leave no protection behind, only a generation dependent upon current, temperature, and chance.
Once the adults depart, benthic predators begin removing exposed eggs.
Slower predators follow chemical traces across the seabed. Smaller scavengers concentrate where eggs were crushed during spawning. Not every predator can exploit the same resource. Body shape and feeding strategy still determine opportunity.
Bottom-feeding fish from neighboring grounds are drawn toward the concentrated nursery.
Adhesion and the shape of the gravel protect embryos hidden below the surface. The same current that transported the adults now sustains the embryos they left behind. In sheltered water, reduced flow allows sediment to threaten the lowest layers.
Only meters away, stronger circulation preserves a far more favorable nursery.
Within each surviving capsule, a recognizable body begins to emerge. Muscles develop before hatching, preparing the larvae for a life carried by moving water. Development follows the temperature of the sea, accelerating and slowing with the surrounding water.
As spring strengthens, the most advanced embryos approach the moment of release.
One transparent larva enters the current with little more than a yolk reserve and the ability to move. As hatching spreads, the wreck creates pockets where fragile swimmers can remain near the seabed.
Their survival will soon depend upon prey almost as small as themselves.
The structure cannot remove danger, but its turbulence may briefly separate predator from prey. The tide finally releases the new generation from the nursery that held its eggs. Some will remain near the reef, while others will travel far beyond the wreck before becoming recognizable fish. The wreck has sheltered the beginning of a generation, but before the larvae can feed, the returning sea will test every. The first hours of life have carried the larvae beyond their nursery and directly into a sea transformed by the approaching storm.
Too small to resist the current, the new generation begins separating into different routes.
A difference of only a few centimeters can determine whether a larva rises into open water or returns toward shelter.
Their muscles allow brief adjustments, but the storm still controls the direction of travel.
Behind the steel, slower water creates a temporary refuge within the turbulence. Light declines as the storm lifts material that has rested beneath the wreck throughout winter. The established residents respond by returning to the structure they already know. The smallest residents occupy passages that exclude both the current's full force and larger animals. The reef's largest resident conserves energy in a depression carved by earlier storms. For animals living close to the bottom, survival depends upon withdrawing before sediment fills the opening.
Spring's youngest colonies face the first physical test of their attachment.
Exposed growth is removed, but settlers protected within the steel survive.
The surface chosen during settlement now determines resistance to the storm. A few centimeters of shelter protect colonies too small to influence the water themselves.
Across the nursery, stronger circulation removes part of the material that threatened the developing eggs. Adhesion holds the surviving eggs in place even as the remains of earlier hatching are carried away.
Even the sheltered side gains a brief advantage when the storm reaches beneath the weakened stern.
For embryos already prepared to emerge, moving water helps release them from the nursery.
A second wave enters the storm without ever experiencing calm water. The wreck gathers lives released from different parts of the nursery into the same temporary refuge.
The refuge lasts only until the current changes direction.
The generation is divided between dispersal beyond the reef and retention within its altered boundaries.
The same tunnel protecting juvenile fish also slows the grains carried by the storm.
Here, reduced turbulence allows the smallest fish to remain above the accumulating sand. Potential predators share the refuge, yet the storm limits their ability to pursue. For several hours, the original outline of the wreck disappears behind moving sediment. Suspension feeders protect the same structures that normally collect food from the current. The youngest attached animals cannot relocate when their surface begins disappearing. Older colonies survive because growth has raised their feeding structures above the moving grains. A hunter relying upon vision abandons water in which pursuit would cost more than it could return. At its peak, the water moves differently across every surface of the transformed vessel. Even loose fragments move only until friction and the seabed restore their balance.
A movement lasting seconds creates another small boundary within the reef.
As the storm passes, the seabed rebuilds itself one grain size at a time.
The residents leave shelter before clear water returns, testing the space immediately around the wreck.
The largest hunter also resumes movement, guided by silhouettes and pressure changes nearby.
Inside the reef, buried residents reopen the passages that connect their shelters to the sea. When the pressure falls, survival becomes visible across the youngest layer of the reef. Material removed by the storm becomes food for scavengers protected within the rough surface. Disturbance clears some surfaces while opening new feeding paths across others. Beyond the steel, survivors of the storm remain separated across a much larger volume of water. Those remaining near the wreck encounter water mixed with the remains of the spring bloom. The energy supplied by the egg is disappearing, and each larva must soon begin feeding for itself. Vision and coordinated swimming develop just as the final internal reserve is exhausted.
Their first suitable prey appears where returning light concentrates microscopic grazers. The transition from drifting embryo to active hunter begins with repeated failure.
Success requires prey to pass within a distance measured in millimeters.
After the storm, survival depends upon whether current has placed each larva beside food.
Feeding improves with illumination because these hunters must first see prey before striking.
As light fades, the current again becomes more influential than their developing vision. The concentration of young fish also attracts predators nearly as transparent as their prey. Even at this early stage, a rapid change in direction can prevent an encounter.
When the flow changes, predator and prey are separated as quickly as they were brought together.
Through late spring, the survivors exchange transparency and dependence for stronger bodies and greater control. As swimming improves, isolated survivors start responding to one another. The first formation is irregular, but collective movement already reduces the danger faced by each fish. Pressure from resident predators strengthens the behavior that will define the young herring's future. Weeks after hatching, the survivors repeat the same defensive movement once used by the adults. From millions of eggs, scattered survivors have become recognizable schools, sustained by the returning productivity of the sea. The storm could not erase the new generation, but its growing schools have now become visible to hunters arriving with the early summer current.
The new generation has survived current, hunger, and storm, but its first organized hunters have now arrived.
Built for sustained speed, mackerel cross large feeding grounds without depending upon the shelter below. Reflected light reveals the position of young fish before either school reaches the wreck. The juveniles respond by reducing the distance between neighbors and moving toward complex structure.
The hunters do not attack the center. They pressure the margin where individuals are most easily separated. A structure that slows the prey for an instant can disrupt a larger hunter for even longer. The school divides across routes too narrow for the entire formation to follow. Some hunters abandon collective movement when a smaller group appears vulnerable. A ceiling only centimeters above the seabed ends the first pursuit without contact. Speed offers little advantage inside a reef built from narrow passages and sudden barriers.
For the wreck's residents, every pursuit also redistributes food through the surrounding water.
The largest resident avoids joining a chase that favors faster hunters.
Separated groups cannot share warnings until movement brings them into the same water.
The hunters position themselves across the easiest escape route before accelerating. With open water blocked, hundreds of fish gather into a temporary defensive mass.
Repeated passes keep the prey together, while reducing the distance to the seabed.
When one fish loses contact with its neighbors, the hunters gain the brief opening they require. The loss produces an immediate response, scattering survivors into the wreck's smallest remaining shelters. A hunter designed for speed cannot exploit every space available to smaller prey.
When fish become inaccessible, the same hunters return to the plankton that also supports their migration.
Their flexible diet allows energy to be collected even when a pursuit fails.
Shelter reduces immediate danger, but it also separates the young fish from their drifting food.
Survival depends upon rebuilding the group before returning to open water.
Within minutes, scattered survivors recover the collective movement interrupted by the attack. The reef now functions as both feeding ground and emergency shelter. As summer develops, the water column begins separating into layers with different temperatures.
Each species follows the conditions best suited to its body and method of feeding.
Between the layers, rapidly changing temperature slightly bends light crossing the water.
Microscopic grazers concentrate where light and nutrients still overlap.
Hunger draws the juveniles farther from shelter as prey becomes richer above them. The same concentration that feeds the prey also makes its movements visible to hunters.
Pressure from above and beside reduces the number of available escape directions. The juveniles abandon the richest feeding layer and return toward the only complex shelter nearby. The chase continues only until steel begins dividing the prey into unpredictable routes. What protects the young fish is not a single hiding place, but the number of choices the wreck provides. The hunter can enter the reef's upper spaces, but cannot maintain speed inside them. Once past the obstacle, collective movement restores the defense that fragmentation briefly removed. Local fish briefly use the migrants' numbers while crossing exposed sections of the reef. Shared danger brings the schools together, but different diets and habits soon separate them. Predation pressure creates opportunities for slower hunters waiting beneath the chase.
A brief movement allows the resident predator to gain from energy spent by faster hunters above.
The surviving fish increase their distance from one danger while approaching the zone used by another. Declining light reduces the advantage of hunters that depend upon rapid visual pursuit. The juveniles return to the structure before vision becomes too limited to maintain precise movement. At night, weaker visual contact changes an organized school into a looser group. While fish reduce their activity, microscopic grazers move upward under the protection of darkness. Across the steel, smaller residents exploit food deposited during the day's pursuits. Darkness also releases bottom-dwelling residents from shelters used during daylight. Food generated in open water eventually reaches animals that rarely leave the seabed. The departure of visual hunters creates an opportunity for a predator guided by scent and nearby movement. Even without a tightly organized school, sudden movement still spreads through neighboring fish. Once again, the wreck protects prey by excluding a hunter only slightly larger than the entrance. A flexible diet allows the hunter to redirect its search when one opportunity disappears. A piece of metal moved only meters by the storm has already become a functioning refuge. Daylight closes the nocturnal hunting period and restores the reef's familiar division of activity.
With vision restored, hundreds of individuals reconnect through distance, direction, and speed.
Through early summer, surviving juveniles gain speed, stronger senses, and the reflective armor of older fish. Growth expands the distance they can travel, but experience keeps the wreck within reach. Predator and prey now share a seasonal feeding ground, shaped by plankton, temperature, and the shelter of a disappearing vessel. The young herring have learned to survive hunters beneath the surface, but the arriving dolphins will transform scattered. The dolphins enter as a coordinated community, turning an open feeding ground into a controlled hunting space. Different positions allow the hunters to guide the school without attacking all at once. The prey responds to immediate pressure, unaware that every turn leads it closer to the structure. By occupying the deeper route, the dolphins remove one of the school's easiest paths of escape. As available space decreases, thousands of individual decisions produce a single tightening mass.
The dolphin's pursuit becomes visible to other hunters already feeding above the reef.
The two unrelated predators now influence the same school from different directions.
The wreck interrupts the compressed school before the dolphins can completely surround it. Roots created by decades of corrosion separate prey into groups too small and unpredictable to control. Their speed and intelligence cannot remove the physical limits imposed by steel. When one school reaches shelter, the hunters redirect their effort toward prey still exposed. Younger members observe the movements that transform individual speed into a successful group hunt. By approaching from below, the dolphins force the fish into a layer where every silver body becomes easier to see. Temperature limits their upward movement, concentrating the school along a narrow boundary.
Repeated passes reduce the perimeter from which isolated prey might escape.
The school's defensive response protects individuals within the center, but creates a concentrated target for the hunters. A successful strike lasts only a moment and removes one fish from the least organized margin. Alternating roles allow the group to feed without releasing pressure upon the school. The faster fish exploit openings created by hunters they are not deliberately assisting.
Every strike pushes the surviving school closer to the only complex refuge beneath it.
The first fish reaching the wreck exchange collective protection for narrow individual shelter. Once an escape path opens, movement spreads through the school faster than any single hunter can respond. The concentrated target dissolves as structure converts one school into dozens of scattered groups. The prey remains visible, but visibility alone cannot create a safe route through corroded steel.
Experience keeps the younger hunter from entering a space where speed would become a disadvantage.
The second group of hunters encounters the same limitation imposed upon the dolphins. For resident fish, the arrival of fleeing prey temporarily transforms quiet passages into crowded corridors. Local predators gain opportunities created by danger arriving from outside the reef. A slower resident needs no prolonged chase when the wreck directs prey across a predictable opening. The dolphins supply movement, while the wreck delivers a single opportunity to the hunter below. After repeated encounters, the survivors reduce every movement that might reveal their position. The hunt pauses as the dolphins restore contact and assess the scattered schools around them.
For the youngest hunter, remaining beside an experienced adult is as important as pursuing prey.
Breathing still ties every dolphin to the surface, limiting the time available for each deep pursuit. The hunters must leave the feeding layer, even when prey remains within reach. A rapid breath restores the oxygen required for another coordinated descent. Rather than wait beside inaccessible prey, the group searches for another school beyond the shelter's reach.
Repeated disturbance has changed the behavior of schools that were never directly attacked.
The contest becomes a race between open water speed and the remaining distance to refuge.
A margin measured in body lengths is enough to break the pursuit. The wreck protects one branch immediately, but the second must continue through open water. The hunting group divides its effort without entering the most dangerous structure. Behind the hull, slower water gives the fleeing school greater control over its direction. Water altered by the wreck weakens the advantage of streamlined bodies built for steady motion. Within the wake, survivors rebuild collective movement before crossing the final exposed gap.
For a second time, the structure ends the chase before another strike can begin.
Each predator reaches the refuge with the same result, preserving the difference between pursuit and capture.
The refuge releases its survivors only after pressure beyond the steel begins to decline.
The rebuilt school carries the shape of the encounter in its reduced distance from shelter.
Hunger forces feeding to continue, even while the movements of hunters remain nearby.
After repeated pursuits, the pod conserves energy and restores its close social formation. Short social contact reinforces relationships that will organize future hunts.
Play and imitation develop the control required to pursue faster prey later in life.
Greater returns draw the dolphins away from juveniles protected by the reef.
The artificial reef loses the hunter's attention once richer prey becomes available beyond it.
Mobile predators leave together not through cooperation, but because the same feeding opportunity draws them outward.
With pressure reduced, local fish reclaim the water column surrounding their permanent shelter. At the seabed, energy from the pursuit reaches residents that never entered open water.
The dolphins have departed, but darkness will replace visible pursuit with a different community of hunters.
Patience. As daylight disappears, squid ascend and sharks leave deeper ground, beginning a night in which concealment. Night brings two different hunters together, one descending from open water, the other rising from the cold seabed.
Within minutes, the familiar boundaries of the reef become difficult to see.
Without strong visual contact, the young herring can no longer maintain the precise formation used during daylight. The squid control their position with fins and gentle jets, conserving energy while searching the water below. Rapid changes in skin pattern help maintain spacing among hunters that cannot rely upon sound.
Even in darkness, nearby movement and faint contrast reveal a concentrated layer of prey.
The sharks approach differently, using chemical traces and subtle electrical signals hidden within the darkness. Every exposed resident becomes vulnerable when a roaming hunter crosses the reef. For the smallest animals, concealment begins with a movement measured in millimeters. The reef's largest resident avoids open movement while unfamiliar sharks patrol above it. The first hunt of the night begins with prey small enough to disappear within the surrounding particles. Two specialized tentacles close the final distance faster than the shrimp can escape. A temporary concentration of drifting prey turns the wreck into a feeding station. By facing the flow, the hunters allow food to arrive without continuously crossing the reef.
Young fish searching for plankton enter a zone now occupied by larger visual predators. A single flash separates one fish from the darkness surrounding its neighbors.
The squid gains speed quickly, but every burst consumes energy that cannot be wasted.
Once again, the smallest passage ends a pursuit before the hunter can strike. Not every fish reaches shelter before another hunter identifies the edge of the group.
A successful strike removes the individual separated farthest from its neighbors.
The survivors abandon open water and exchange feeding opportunities for immediate shelter. Flexible hunters turn back to smaller prey when the wreck removes fish from reach. Particles dispersed through the water guide the sharks toward a feeding event they cannot clearly see. The hunter from below enters the same water, occupied by predators now becoming prey.
A rapid color change accompanies the sudden expansion of the shoal.
The shark follows the individual whose escape route has been narrowed by the wreck. Ink briefly disrupts the shark's approach, but moving water begins dispersing the screen immediately. The cloud delays the pursuit, allowing the squid to replace speed with an unexpected turn. A shelter first used by young herring now protects one of their hunters from a larger threat.
The reef divides every pursuit into opportunities and limits, regardless of which species is hunting.
Away from the steel, fewer barriers remain between sustained pursuit and capture.
Jet propulsion produces rapid escape, while the shark's streamlined body supports a longer pursuit.
Returning to structure offers the squid its only immediate chance of breaking the pursuit. A gap little wider than the squid's mantle becomes a refuge from both sharks. The sharks separate because chemical traces spread across more than one route.
The shark's altered path exposes a resident that played no part in the original pursuit.
Burial removes both movement and electrical contrast from the water immediately above it. When one signal disappears, the hunter continues along a boundary where currents collect traces from many animals.
The young fish remain protected only while darkness keeps them inside the narrowest shelter.
Chemical evidence reveals prey nearby, yet the shark's body cannot pass through the opening.
Even without contact, pressure changes carry evidence of the hunter into the shelter.
Stillness reduces the signals available to a predator searching beyond the steel.
A resident hunter enters the same route only after the larger shark has passed. Unlike the squid, the eel searches slowly through water, carrying chemical evidence of recent feeding. Two nocturnal hunters meet, where the hull compresses their paths into the same narrow corridor.
Either hunter gains enough advantage to justify the risk of close contact.
The encounter ends through separation, conserving energy and preventing injury to both animals.
Safety returns briefly, allowing bottom dwellers to recover food deposited during the night.
Material missed by hunters transfers energy from the plankton layer to the seabed community.
Across the wreck, smaller residents benefit from food broken apart and redistributed by current. Even animals fixed permanently to the steel receive the remains of distant pursuits. Changing tide begins reorganizing the reef before the night has ended. The wake offers relief from the current, concentrating squid that had spread across open water. Food passes within sight, but leaving shelter would expose the young fish to squid waiting outside. Hunger produces short movements, measured against the distance to safety. At the wreck, a successful feeding journey can last less time than a predator's response. The first returning light ends the sharks' period of greatest access to the reef. The squid follow the retreating darkness toward deeper water, where their pale bodies remain concealed. With vision restored and nocturnal hunters departing, scattered survivors reconnect above their shelter. The night hunters have withdrawn, but daylight introduces a powerful visitor able to combine speed, vision, and close maneuvering inside the reef. A hunter from the sky crosses the surface at speed, carrying the pursuit into a world where it can remain for only seconds. Folding its wings before impact protects fragile bones and transforms the bird into a streamlined projectile. The school responds to danger from above by moving toward deeper water and the distant shelter of the wreck. Vision adapted for both air and water identifies the individual left outside the moving formation. Momentum provides speed, but the smaller fish retains the advantage of a tighter turn. Once the force of the plunge fades, powerful wings extend the pursuit through the upper water. Reconnection removes the single target and replaces it with a wall of rapidly changing reflections. Air trapped within the bird's body assists its return to the surface when the short pursuit ends.
One unsuccessful dive still reveals the exact position of prey to every hunter watching from the air.
Each bird selects its own approach, reducing the chance of striking another diver.
A staggered assault keeps pressure upon the school without filling the water with competing bodies.
For an instant, the surface follows the bird downward before collapsing into bubbles behind it. Fish detect the disturbance before the bird reaches them, opening a temporary channel through the school. A new hunter arrives before the school can rebuild its defensive formation. This time, a fish separated by the first disturbance remains exposed long enough for capture.
Holding the prey along the bill reduces resistance during the rapid return to air.
The fish is swallowed underwater, preventing it from being lost during the final ascent. The wreck now protects the school from an attack that began far above the sea. A body designed to strike open water cannot safely pursue prey through rigid frames. The birds wait at the surface, but their prey has moved beyond the depth and structure of an effective plunge. Feeding resumes first along the outer boundary, where food is abundant but protection is distant.
From the surface, brief reflections reveal that the school has begun returning.
Without the height required for a plunge, the surface hunter cannot reach fish several meters below.
To attack again, The heavy seabird must first recover enough altitude to convert gravity into speed.
Repeated dives are visible across great distances, attracting other birds searching the same water.
Danger is now visible before each plunge, compressing the feeding school toward shelter. The birds are not the only hunters responding to a concentration of vulnerable fish. Pressure from below drives the prey toward danger waiting at the surface. Pressure from below drives the prey toward danger waiting at the surface. Repeated attacks shorten the school until its outer fish remain within reach of hunters on both sides. For a moment, hunters from air and deep water occupy the same narrow feeding zone.
Shared opportunity also creates interference, forcing each hunter to avoid the other.
A fraction of hesitation opens an escape route through the center of the hunt.
Steel separates the compressed school into smaller groups that neither bird nor mackerel can follow. When the main school vanishes, flexible predators redirect their effort toward whatever remains accessible. The visible feeding event weakens as prey disappears into the wreck. Interlocking feathers and protective oils preserve insulation through repeated impacts with cold water. Air retained among the feathers adds insulation and increases buoyancy after every dive.
Residents too small to attract the gannets recover food redistributed by the pursuit.
At this depth, the largest resident is unaffected by hunters specialized for prey near the surface.
Material lost during the hunt descends through the reef and transfers energy to the seabed. What cannot be consumed by fish or crustaceans continues toward animals fixed within the sediment. A change in tide moves the feeding layer beyond the shelter that concentrated it.
The school must move with its food, extending its range along the structure. Movement along the wreck becomes visible from the air as sunlight returns from a new angle. The renewed distance from shelter creates another brief opportunity for attack.
A later arrival uses the school's first escape movement to shorten its pursuit. An exposed crossing ends with one fish taken only moments before the others regain cover. A narrow piece of wreckage again marks the boundary between capture and survival.
Without repeated flashes near the surface, the birds lose the signal that brought them together.
Some hunters continue searching, while others pause to recover from repeated high-speed impacts.
The survivors reconnect within slower water, carrying fewer individuals than before the attack.
The underwater hunters leave when currents remove both prey and feeding advantage.
As immediate pressure declines, hunger once again draws the school away from steel.
A larger transformation approaches, one no predator can control or avoid. Broken reflections erase the visual signals that guided each plunge. The birds depart before rising seas make takeoff and precise diving increasingly costly. Energy from the approaching weather is already reaching animals hidden below the waves. The reef community abandons exposed feeding positions before the storm reaches full strength. Water that once carried plankton now begins testing every exposed surface of the wreck.
The hunters have departed, but the coming storm will penetrate every opening, move the seabed and reshape the boundaries upon which this community depends.
The storm has reached the reef, carrying energy from the darkened surface into every exposed opening below. The hunters from the sky have departed, leaving the storm as the only force moving across the reef. Each passing swell produces an underwater surge that changes direction within seconds.
The school abandons open water and aligns against the current to avoid being carried beyond the wreck.
Even during the storm, the hull creates a narrow wake where the force of the surge is reduced.
Resident fish use the deepest chambers, where layers of corroded steel interrupt the moving water. The largest resident reduces its exposure by entering the deepest depression beneath the hull.
For bottom dwellers, survival depends upon maintaining contact with a surface when the current cannot move.
Flexible bodies yield to the current, reducing the force placed upon their attachment points. Animals unable to leave the wreck protect delicate feeding structures until clear water returns. Across the seabed, exposed suspension feeders close before the strongest sediment arrives. The current now returns along the same route, removing sediment deposited only moments earlier. Different particles separate according to their weight, reshaping the seabed one layer at a time. Material accumulated over earlier seasons is stripped away within a single storm.
The moving seabed releases animals that normally remain concealed between grains of sand.
Even destructive water can deliver brief feeding opportunities to animals sheltered from its full force.
As the storm intensifies, water reaches chambers that remained calm during the first waves.
The school can no longer remain as one formation, but smaller groups fit more securely between the ribs. Every change in direction demands energy, gradually consuming reserves normally used for feeding and growth. Steel, weakened through decades of oxidation, begins responding to forces that living residents can only endure.
One small structural change redirects the current into a section previously protected from direct flow.
A refuge that functioned minutes earlier becomes an exit through which its smallest residents are carried.
Food and danger arrive together, allowing only seconds before the current changes again.
Cloud, waves, and suspended sand remove the visual boundaries that normally organize the reef.
When sight is reduced, contact with water movement and nearby structure becomes increasingly important.
The eel leaves an exposed entrance and follows the cavity toward its deepest protected end.
The same current that deepened the refuge begins narrowing one of its entrances.
A second opening prevents the changing seabed from converting shelter into confinement. Different residents converge upon the few spaces where water speed remains low. During extreme disturbance, conserving position becomes more important than competition for territory. Small impacts accumulate upon metal that has endured decades beneath salt water. The structure flexes before it fails, transferring force through its remaining attachment. The storm removes one familiar boundary without destroying the larger wreck. Every lost structure closes one pathway and creates another. Residents respond first to movement and changed water flow, long before exploring the new opening.
The altered structure immediately offers protection to an animal displaced from an older refuge.
Sediment begins fixing the broken structure into a new position before the storm has ended.
living growth follows every reversal, while the steel beneath it absorbs the same repeated pressure. The storm removes exposed growth, creating space that future colonies may occupy.
Survival favors individuals attached below the level of the strongest current. Above the wreck, wind transfers its greatest energy into the sea.
The reef disappears inside material lifted from the surrounding seabed.
The open water school has become a collection of small groups hidden throughout the steel.
Oscillating water releases small pockets of gas, preserved within irregular spaces.
Strength is used not for pursuit, but simply to prevent displacement from the reef.
A few centimeters of rock and steel separate stable shelter from the moving seabed outside.
Poor visibility and powerful currents remove the hunting advantages of speed, vision, and surprise. The protected wake becomes a temporary reservoir for material removed from every exposed surface. The storm begins moving beyond the reef, and the water gains brief moments of reduced force. Visibility returns from the top of the wreck downward as heavier particles begin settling.
The separated groups begin reconnecting before conditions outside the wreck are fully calm. Residents encounter a structure changed during the hours they remained hidden. A route created by structural failure becomes part of the reef's shelter network. The resident returns to a familiar territory whose boundaries have shifted. Erosion exposes food that had remained inaccessible beneath the old seabed.
The first feeding after the storm begins upon ground created by the storm itself.
Animals fixed to the wreck reopen when sediment falls and water movement returns to a manageable level. Food reconnects the sheltered community with open water, rebuilding the pattern that existed before the storm.
The reef has endured, but its entrances, currents, and exposed surfaces now form a different habitat.
Once built to cross the ocean, the fallen vessel now survives through the life it shelters. Changing with every... From open water comes a migration large enough to transform every feeding relationship around the wreck. The first arrivals follow plankton carried across the continental shelf by cooling seasonal currents. A large structure interrupts their route, dividing both the current and the approaching school. The shoal separates around the steel and reconnects within the slower wake beyond it. Resident schools surrender the exposed feeding layer to faster visitors arriving in overwhelming numbers. Young residents remain within the shelter network as unfamiliar bodies fill the open water. The wreck's largest resident stays near the seabed, separated from the migration by depth and habitat. 4 layers of fish now occupy the same reef, each using a different combination of water and steel.
Food reaches the visitors as a concentrated pulse, transported by the tide.
Each fish filters or selects tiny crustaceans without interrupting the forward motion of the school. Their patterns break individual outlines when thousands of bodies turn within the same shifting light.
A seasonal migration now passes over communities that began life only weeks earlier. Not all captured energy remains in open water. Some begins falling toward animals fixed below.
The smallest residents benefit from feeding activity occurring many body lengths above them. Hidden scavengers intercept material before it disappears into the sand. The migration feeds animals that will never enter the water column above the wreck.
For the reef scavengers, abundance arrives indirectly from a school moving overhead.
The wreck concentrates plankton inside water, slowed by its own shape.
Successive waves of travelers expand the school until it surrounds the upper half of the wreck.
Movement in the school changes the light reaching residents below.
Reduced contrast briefly allows small residents to feed beyond the protection of steel. A resident predator tests the boundary between sheltered reef and open water migration. The shoal detects pressure from below and transfers the warning through rapid changes in direction.
A single hunter cannot easily isolate prey, protected by thousands of moving neighbors.
The opening closes immediately, leaving the predator outside the rebuilt formation. Multiple residents now exploit the migration, but each still hunts independently.
Separate attacks overlap by chance, narrowing one group's escape route. The smallest fish seeks protection inside a space too narrow for the pursuing predator. A momentary separation transfers one traveler into the permanent food web of the wreck. Distance from the structure reduces surprise attacks, but also carries the school into faster water.
The migration has attracted hunters that do not depend upon the wreck for shelter.
Fast pelagic predators arrive where concentrated prey offers repeated opportunities.
Pressure from open water drives the travelers back toward the structure they had avoided.
The school becomes trapped between hunters adapted to two different layers of the reef.
Fragmentation prevents the entire migration from being contained within one attack.
Speed succeeds in open water, but the approaching steel limits the pursuit.
A predator built for acceleration cannot safely follow every turn around the wreck.
Visitors and residents share the same narrow refuge, while predators remain outside. Protection from one predator does not remove every danger within the reef. When the fish returns to open water, the resident uses a short vertical ambush.
A final change of direction preserves the traveler as the heavier hunter loses momentum.
Failed pursuit costs energy, encouraging the resident to wait for another closer opportunity. A larger hunter now enters from colder offshore water, guided by the abundance of fast-moving fish.
Unlike resident hunters, the shark remains in open water, where its speed and endurance are greatest.
Only the threatened side responds at first, allowing information to travel through the school.
The shark attacks from below, using darker water to conceal its final approach.
Most escape through collective movement, but individuals outside the formation lose its protection.
A single exposed fish is taken before the school can close around it. Momentum carries the hunter back into open water, where another approach can begin.
The wreck becomes the center of a moving boundary between shelter and attack.
The food that brought the migration begins leaving the reef with the changing tide.
Hunger gradually overcomes the protection offered by steel.
The migration stretches across open water as thousands of individuals resume their seasonal journey. Mobile predators leave with the prey, carrying the brief concentration of danger away from the reef. Fish, unable to match the school's speed, face the greatest risk during the final departure.
Rejoining the moving formation restores protection before the shark begins another approach. With prey spreading across the shelf, the hunter abandons the wreck and continues offshore. When the travelers leave, the reef's smaller schools return to feeding grounds temporarily taken from them. The abundance of early autumn is ending, and every resident begins conserving energy for the colder season. The great school has passed, taking its hunters with it, but winter is already approaching, a season when food will... The migration has passed, leaving the reef beneath a sea already beginning its descent into winter. Shorter days and stronger winds reduce the light, reaching even the highest ribs.
The remaining school moves closer to steel as open water becomes colder and less predictable. Young residents reduce unnecessary movement, preserving energy when feeding opportunities become rare. The largest resident also becomes less active, waiting rather than searching across an empty seabed. Winter compresses the community into the most protected layers of the wreck. The rich plankton layers of summer have been replaced by isolated prey transported through colder water. Each small crustacean now justifies a short departure from shelter.
Most searches consume energy without providing anything in return.
Inside the wreck, prey concentrated by slower water remains more dependable than food outside. A single capture immediately attracts competition among fish sharing limited shelter. Dividing the available space reduces conflict while allowing both fish to watch the current. Even protected entrances become exposed when winter currents strengthen. Animals attached during summer survive by sealing themselves against abrasion and lost feeding time. Delicate colonies endure the current by reducing the surface exposed to its force.
A depression only millimeters deep provides protection against water moving across the open plate. Hidden suspension feeders continue collecting particles without leaving the security of the wreck. In winter, even one descending fragment becomes valuable energy. Scavengers wait at the boundary between shelter and the moving seabed.
The current occasionally delivers food from beyond the reef without requiring a long search.
The first animal to reach the fragment gains an advantage measured in only a few calories.
Nothing edible remains unused when the season provides so little.
Winter night begins long before activity across the reef has completely ended.
The school reduces its exposed outline, while darkness removes the protection of early detection.
Complex steel allows residents to survive the night as scattered individuals. For one nocturnal hunter, darkness creates the safest time to leave its narrow shelter.
Chemical signals remain useful where vision has become limited.
The prey reaches a crevice before the hunter can turn its head into the opening.
Energy cannot be wasted pursuing prey, already protected by steel. A brief reduction in water movement releases small prey from the seabed. Tiny prey provide limited reward to a hunter built for larger opportunities. For smaller fish, the temporary swarm offers exactly the size of food winter has removed elsewhere. The feeding opportunity ends as quickly as changing water created it.
Every resident withdraws to shelter before the next period of strong flow.
Each winter tide rearranges the boundary between open chambers and buried steel.
A familiar route narrows overnight, changing how small fish move through the reef. Smallest residents can still use the passage, but its protection has become more selective.
A few centimeters of sand redirect larger fish through more exposed water.
The altered route briefly removes the resident from structural protection.
Winter scarcity encourages a larger resident to investigate any vulnerable movement. A change in pressure behind it warns the smaller fish before the pursuit begins.
Straight-line power becomes less useful when the escape route enters complex steel.
The storm-created entrance again protects a fish small enough to cross it. Further pursuit would consume energy the winter predator cannot easily replace.
Survival depends upon remaining inside shelter until the danger has moved away.
Before the reef can recover from one disturbance, the next winter system reaches the shelf. Material deposited during calm water is returned to suspension by the strengthening sea. The school moves downward before visibility and stability disappear completely.
Animals using different parts of the wreck respond with the same retreat toward protected spaces.
A body too large for the frame network depends upon the calm water created beneath the hull. The wreck interrupts sediment transport, building small barriers around its buried side.
Moving debris changes the entrance to a shelter occupied throughout the year.
An added barrier reduces the current, but also narrows the only route back into open water.
Corrosion continues even in winter, removing another thin layer from the aging structure.
The wreck yields to the sea in small movements, rather than one final failure.
As the storm moves away, the reef reappears beneath material redistributed across every surface.
A surface changed by the storm immediately becomes another layer of shelter.
Changed water flow concentrates the first food available after hours of confinement.
When the current becomes manageable, mobile and fixed residents resume activity together.
The reef has survived the first winter storms, but scarcity now draws a warm-blooded hunter capable of entering the wreck's most exposed boundaries.